Hello. The last part of our equations review or topic is going to be an interesting one. What we're going to do is to explore something we haven't seen before, and that is the equation of a line in a different form. Take a look at these two equations. 3x plus 5y equals 10, and negative 6s plus 4y minus 15 equals 0. I'm going to show you what they look like in Desmos. So here is the first one. And when I graph it, oh, I notice it's a straight line. And the same thing for this one. And this is true because if we remember, our variables all have exponent 1. So this form is sometimes called standard form of a linear relation. And what we're going to do is going to try to connect this form with a form that we know, y equals mx plus b. Because if we look at this equation, 3x plus 5y equal 10, it's hard for us to determine the slope or the y-intercept right at the bat. And the same thing with this one. So what we're going to do is we're going to use what we have learned to isolate, to solve the equation for y. And when we do that, our equation is going to look more like y equals mx plus b. So let's take a look at how we do that. Well, this is our equation that we begin with, the first example. And just like we've been doing, we're going to use inverse operation to isolate the y. Okay, so if that is the case, the first step we're going to do to isolate the y on the left side is subtract 3x on both sides. And the result, we're skipping a couple of steps, but by now you're probably very comfortable doing this. If I subtract 3x from the left side, it disappears and end up with 5y, and then I subtract it from the right side. So right now I have 5y equals to 10 minus 3x, and then I'm going to just divide both sides by 5 to isolate the y. When I do that, I end up with y by itself on the left side, and I end up with what we had before, 10 minus 3x divided by 5 on the right side. And then, of course, I can see that this is equivalent to 10 divided by 5, and then negative 3x divided by 5. 5 is a denominator for both the 10 and the negative 3x, and this is what I have. And of course, I can see now that 10 divided by 5 is 2, and here negative 3x over 5x. Take a look. So now I have this equation as y equals b plus mx, really, but that's okay. I can identify that the slope is negative 3/5 and the y-intercept is 2. Let's see if that is the case. So our equation would be 2 minus 3/5 of x, or y equals negative 3/5 of x plus 2. Y equals negative 3/5 of x plus 2. And that's our equation. And I know that this is correct because it overlaps the first one. Take a look. I'm going to make this equation dotted so I can see when I overlap my second equation how it shows on top of it. So these two equations really represent the same line. What we just did was use our tools that we use for equations to isolate the y and therefore write this equation that is in standard form as y equals mx plus b. Okay, so now we're going to do another example. The second example, negative 6x plus 5y minus 15 equals 0. This really is the perfect form for a standard form. And sometimes we call these ax plus by plus c equals 0 form. But for now, we're just going to call it standard form. And we want to also isolate the y because then we have y equals mx plus b form. So let's begin by doing some of these steps. Sometimes by now we are proficient and we can do 2 or 3 steps at once. So let's say here that we could add 6x on both sides and also add 15 on both sides. If we did that, we would have 4y on the left side, and then because this is 0, we would have positive 6x plus 15 on the right side, which is what we have here. And all we have to do next is divide by 4. When we do that, our equation becomes this: 6x plus 15 divided by 4, and we have to be aware that this 4 is a denominator for 6x and for 15. So when we rewrite this, we end up in this form: y equals 6x over 4 plus 15 over 4. If we rewrite to reduce our fractions, 6 quarters is the same as 3 halves, and 15 fourths we cannot reduce. So now this is the equation in y equals mx plus b form: 3 half of x plus 15 over 4. And so we can verify that here. I'm going to hide this one, and I'm going to write it here. We said it was y equals 3 halves of x um, plus 15 quarters, and that's our line. Let's see if we match the other one. It does look like they do overlap. Take a look. So we just learned a new form for our linear relations, and we learn how to go from one way to the other, from standard form, this form, to y equals mx plus b form. Now you're going to practice a few questions here. Have fun.